Here are some of the basic skills of right triangle trigonometry. One of the first and most important parts of right triangle trigonometry is correctly labeling all three sides with the letter O, A, and H. O is going to represent the side, a leg of the right triangle that is opposite or opuesto of the angle that you are utilizing. The A is going to be the side and the leg of the right triangle that is next to or adjacent or al lado the angle you are using. The H will always be the H, and that is the hypotenuse. So let's take a look at some examples. There are two acute angles of all right triangles that you could use to be the point of reference. So for example, if we're utilizing the angle, which is down here, I'll put a little X there. I like to draw an arc, which I call the bow, and then I draw an arrow that is in the bow, and I shoot it across the triangle, and this side will always be the O, opposite of the angle that we're going to be using. The hypotenuse never changes, so I usually put that on the hypotenuse second. And then the third side, the side that's next to the angle, that's the leg, is the A, the adjacent side. Now, one thing that's extremely important to remember is that sometimes you might be using the other angle in right triangle trigonometry. And if you're using the other angle, the two letters that are going to change are going to be the O, which is now down here. The hypotenuse doesn't change, and the other one that does change is your A. So be very, very, very careful about how you place the O, A, and the H, because it is extremely important in all right triangle trigonometry problems. Why don't you pause your screen for a moment and see if you can correctly label all three of these triangles with an O, A, and H. Okay, let's take a look at the first triangle in the upper left-hand corner of your screen. Well, the angle that we're using is marked with an X, so I'm going to use my bow and my arrow, and I'm going to shoot it across the triangle and mark my opposite side. The hypotenuse will always be the diagonal across from the right angle, and the last leg is my adjacent. Let's look at the problem in the upper right corner. You can see that the right triangles can often be rotated in different ways, but that doesn't stop us from correctly labeling this triangle. Here's my angle, there's my bow, there's my arrow. So this side is going to be my opposite. The diagonal across from my right angle will always be my hypotenuse, and the other leg is my adjacent. Here in the bottom left, you can see the X for the angle that we're going to be utilizing. So there's my bow and there's my arrow, and this side will become my opposite. There's my 90-degree angle, so here's my diagonal, my hypotenuse, and the last side will be my adjacent. And finally, in the bottom right corner, we have our angle. I'm going to do my bow and arrow and mark my O, my H, and my A. Now, many of you have already seen these three funny words, so, ka, toa. Well, these three words are extremely helpful in helping us create our right triangle trigonometric equations. Let's see how they work. I'm going to draw a right triangle for each one of these. So I'm going to put a little right triangle there, one here, and one here. And I'm just going to randomly create 3 separate problems. So in this first right triangle, I'm going to put my right angle, and I'm going to just put in an angle here, say of 50 degrees, and here, and one of the legs, I'm going to put an X, and here I'm going to put, say, the number 12. Well, let's see how SOHCAHTOA can help us. Well, as we've already stated, the first step is labeling all 3 sides with an O, A, and an H. So I'm going to do that with this particular triangle right here. Well, since they're giving me a 50-degree angle, I'm going to use that one and put a little bow there and put an arrow. And I'm going to say, well, this side where my X is, that's going to be my O. Here's my right angle, which means the diagonal was always my hypotenuse. And then down here, this last one is going to be my A. Now, the thing with right triangle trigonometry is that we're only going to utilize one angle, one acute angle, and 2 sides in every problem. So in each problem, there's going to be one side that you do not use. Well, in this particular problem, I certainly need my O, because that's the side I'm looking for, labeled X. I certainly am going to use the 12, because they gave that to me right there, the 12 feet. So I'm going to be using my O and my H, and there's no number, there's nothing here down by the letter A, so I do not need my A, so I'm going to cross it out. And I see that I'm left with an O and an H. Now, when I look up at SOHCAHTOA, I realize that there's only one of those that has an O and an H. And therefore, this SO is what I'm going to choose, so that S is going to help me decide which function. Now, if you forgot already the names of the functions, you can always just look down at your calculator. And you could see the 3 buttons that we use for trigonometry are called sine, cosine, and tangent, or the 3-letter abbreviations SIN, COS, and TAN. So the S in SO represents sine. So I'm going to write underneath this triangle sine. After I've chosen my function, I'm always going to connect to the function the angle that I'm using. In this case, I'm using a 50-degree angle, so I'm going to write sine 50, and I'm going to put an equal sign and a line to start a fraction. Now, SO not only helps us decide which function to choose, it also tells us where to put the O and where to put the H. The letter that comes first, in this case the O, will always go on top. In this case, my O is my X, and the H will go on the bottom right there. Sine of 50 is equal to X over 12. All right, let's look at another problem that we might have. I'm just going to put in my right angle. I'm going to use this angle this time. I'll say this is 40 degrees, just making up some numbers here. I'm going to say that this is an X, and I'll say this is 8. Again, I'm just making up some numbers here. Well, if I start this problem the way I start all trigonometry, right trigonometry problems, I'm going to put a bow for my 40-degree angle, and I'm going to shoot an arrow across the triangle and label my opposite side. I know that the diagonal is my hypotenuse, and then this last side is my adjacent, the leg which is next to my angle that I'm using. Well, in this case, remembering that I'm only going to use 2 sides, I'm going to cross out the O, because that's not what I'm looking for, and there's no number there to help me. Well, in this particular case, I see that there's an A and an H. Well, an A and an H, there's only one of SOHCA and TOA that has an A and an H, and that's this one right here that begins with a C. The C, if I look at my calculator to remember, oh yeah, that's my cosine. So I am going to start this problem with cosine. Again, putting the angle, attaching it to the function. I'm going to put an equal sign and open up a fraction. Well, ka also helps me remember which to put on top and which to put on the bottom. Well, the a is going to go on top. In this case, it's 8. And the x is going to go on the bottom because that is my h. The cosine of 40 is equal to 8 over x. And now we're going to get to our last problem. You can probably already guess which two sides are going to be involved, but let's just take a look at it anyway. Let's call this a 61-degree angle. I'm just making up these numbers. I'll put an 8 over here and a x over here. And finally, we're going to go through the same process. This is the angle. Here's my arrow. This is going to be my O. This is going to be my H. This is going to be my A. There's only one side that I'm not looking for and has no information. That's my H, which I do not need in this problem. So I'm going to use my O and my A. Well, out of SO, KA, TOA, only TOA has an O and an A. And that TOA stands for tangent. So I'm going to write the tan 61 degrees is equal to fraction. The O comes first, so that goes on top. And the A comes next. That happens to be my X. So I'll put that one on the bottom. And that is how you set up a right trigonometry problem. Let's continue to the next page. Okay, once you're able to set up a problem, there really are 3 different scenarios that you need to practice. So before we continue, why don't you press pause on your video and see if you could set up each of these problems. If you set up each of these problems and discovered that each one of these problems is a tangent problem, you are absolutely correct. Here's your angle, here is your O, and here was your A. With an O and an A, it's a tangent problem. Here's your angle, here's your O, and here's your A. With an O and an A, yes, it's also a tangent problem. Even though the angle here is what we're looking for, it's the X, that's the one I'm going to use. This is our O, here is our A. Yes, it's also a tangent problem. And if you set these up, the first one should be the tan of 35 is equal to x over 15. The second one should have been the tan of 42 is equal to 12 over x. And finally, the last one is the tan of x is equal to 8 over 10. Now, the reason why I used tangent for all of these problems was to show you another very important skill, which doesn't have to do with the function you're using. Because regardless of whichever function you end up using in right triangle trigonometry, you might have an x or a number you're looking for that ends up on top of the fraction, like the first example. Tan of 35 equals x over 15. You might have a tangent problem or a cosine problem or a sine problem where you end up with a function that has x on the bottom, like the middle problem. And you might also have a problem in right triangle trigonometry where x is the angle you're looking for. So we need to be able to solve for each of these scenarios. So let me show you a quick way to solve for x for each one. Let's look at x on the top first. When x is on the top, it's a quite simple process. When x is on the top, I try to treat the tan of 35 as if it's also a fraction. And any number could be changed into a fraction by putting it over 1. Now it becomes really easy to just cross multiply. Well, I'm going to start here on the upper right with the x, and I'm going to multiply it with the bottom of the other fraction, which is 1. And what's x times 1? X is equal to. Now here you got to be a little bit careful, because when I multiply 15 times tan 35, I don't want to accidentally multiply that 15 and that 35. So therefore, when I multiply a number like 15 with a function and a number like tan 35, I'm always going to put the 15, the number, in front, and then write tan 35. And therefore, when you put that into your calculator, it's automatically going to multiply. All right, let's look at this second problem. Now, some of you may have already seen in one of my classes the reason why I come up with this particular shortcut. So I'm not going to explain it here right now in this video, but I'm going to remind you that when x is in the bottom, we're going to use what Mr. Frank calls the volleyball trick. I'm going to take this number on top of the x, which is a 12, and I'm going to throw it to the other side of the equal sign, and it's going to end up landing right on top of the tan 42. And then the x will be all by itself on the other side of the equation. So what we're going to end up with is 12 divided by tan 42 is equal to x. So when we put that into the calculator, we just need to remember to use division. Finally, our last example is when we are doing right triangle trigonometry backwards. And some people like to think of backwards as working in reverse. Instead of using an angle and a side to find another side, we're using the two sides to go backwards and find the angle. And in math, sometimes we like to call doing things in reverse the inverse, which is why in this particular case, when we're looking for an angle, we use what's called the inverse function. The inverse function is usually represented by something to the power of -1. And you might notice that if you look at your calculator, you could see that above in blue of each of the sine, cosine, and tangent buttons are the same functions to the power of -1. Those are the inverse functions. So in this case, all I'm going to do is to take the tan, and I'm going to pull it off the x and throw it to the other side and change it to its inverse. So the tan becomes to the power of -1. And then automatically your calculator is going to open up a parentheses, and we're going to drop in the 8 divided by 10 and close it. All right, so that represents the 3 important scenarios. But in all of these, there's one more important step. I like to call all of these steps the 3 S's. S, S, S. I like for all trigonometry problems to have 3 steps. The first one, which we've gone through, is the setup. Each of these were set up right at the beginning. The tan of 35 is equal to x over 15. The tan of 42 is equal to 12 over x. In this case, the tan of x was equal to 8 over 10. Then we do our second S, which I call the solve. The solve is, well, how am I going to get x alone on one side of the equation? How can I get it to read x is equal to something? Well, in the first scenario, we cross-multiplied and got x is equal to 15 tan 35. In the second one, we used the volleyball trick, and we got x is equal to 12 divided by tan 42. And in the third scenario, we solved for x by using the inverse function. We said x is equal to tan to the -1, 8 divided by 10. Well, the last part of all trigonometry problems is writing the ultimate solution. Well, that requires that you put each one of these into your calculator. So let's do them together, and let's round each one off to the nearest tenth. So here we go. I'm going to pick up the calculator, and let's start with the first one. The first one is a simple one. It just requires multiplication. But when you have a number right next to one of the functions, you don't need to press the multiply button. We can just put in 15 tan 35, close the parentheses if you like, and hit enter. And we can see that to the nearest tenth, x would be equal to 10.5. Then we get to the second problem. And the second problem is division. Well, we have to remember to put the division into this one for sure. So we're going to put 12. Well, hold on, go back. 12 divided by tan 42. Enter. And you could see, rounding off to the nearest tenth, we could write x is equal to 13.3. X equal to 13.3. And finally, the last problem, looking for the angle here, we're going to use the second button, then the tan button, and we can see that tan to the power of -1 came up, and open parentheses, and we're going to put the fraction into the parentheses, 8 divided by 10, enter, and we can see that our angle will be equal to 38.7 degrees. And that right there are the most important basic skills in right triangle trigonometry. So before we finish, let's just go to one more page and see if you could do all 3 S's, the setup, solve, and solution for these 3 problems. Go ahead, press pause. Okay, let's check our answers. So I'm going to do these kind of quick. So here we go. Number 1. Here's my angle. There's my bow and arrow. Here's my O. Here's my A. Here's my H. I don't need the A. So this is going to be an O and H. It's going to be a sine problem. So the sine of 50 degrees is equal to the O over the H, which means it's x over 18. Now this is an x on top scenario. So I'm going to put the sine of 50 over 1 and cross multiply. I'm going to get x is equal to 18 sine 50. Now, finally, I just need to put that into my calculator. So I'm going to go 18 sine 50. Enter. I get 13.8. X is equal to 13.8. How did you do? Let's try number 2. Okay, well, there's my angle. I'm going to use this 35-degree angle. Here's my bow and my arrow. Here's my O. Here's my H. Here's my A. I need my O. There's a 30. I need my A. There's an X. I don't need my H. This is an O and an A. Which one of these has, oh, must be a TOA problem. So TOA stands for tangent. So I'm going to use TAN of 35 degrees is equal to, it's going to be my O over my A. So that means 30 over X. This is a problem that has X on the bottom. I'm going to use the volleyball trick. 30 is going to fly to the other side and land on top of tan 35, and that's going to be equal to X. Let's get out the calculator. Whoops. Let's put in 30 divided by tan 35, enter, and we can see that that's going to be equal to 42.8. X will be equal to 42.8. And then we get to the final problem of the day. And in this case, well, looking for an angle, well, that means I need that angle. So that means this side here must be my O, and there's my right angle. So this must be my H, and this will be my A. Well, the one side that it looks like I don't need is my O. There's nothing there. So I'm going to use an A and an H, and that will be a cosine problem. So I'm going to write cosine of x this time is equal to a fraction. Ka is A over H, A over H, which is 14 on top and 20 on the bottom. Now in this case, I'm looking for an angle, so I'm going to use that inverse trick. I'm going to keep my x over here and throw the cosine to the other side, but I'm going to use the inverse function to the power of -1, open up my parentheses, and drop down the fraction. And now finally, we're going to go to the calculator. I'm going to hit the second button first, and then the cosine. There's my cosine to the power of -1. I'm going to put 14 divided by 20, enter, and that gives us 45.6 degrees. X is equal to 45.6 degrees. Well, there you have it. I hope that that was helpful in reviewing your right triangle trigonometry skills.